All right, so pick up where we left off. We just finished the proof on the previous one there. We were proving how where we got the derivatives functions for all the trig values were. We applied the quotient rule, and we were able to use our identities from before to get uh, the appropriate derivative for those ones. All right, so let's differentiate a couple using some trig functions. So I just have two for us on this section. The first one, we're looking at y equals x minus tangent of x. They're pretty easy here. All right, so y prime, remember we have that rule that says if it's just adding and subtracting two together, just do each individual term. So what's the derivative of x? Be 1. Be 1, okay? A constant is 0, just a variable is 1, okay? And then minus tangent of x, so we have minus, what's the tangent of x? Derivative of tangent of x. Last theorem we had. There you go. Minus secant squared of x. Bingo. That's all you gotta do for that one. That's it. All right, that wasn't a product rule, quotient rule, anything like that. Now, second one here, this one does have a little more work to it because y equals x secant of x. So now this one we have, remember before if we had a 2 and then the trig function, we could just use the constant multiple rule, right? Just the 2 just kind of hangs out, differentiate the trig function and multiply. In this case, though, this would be multiplication because they both have x's with them. All right, so now we have to apply the product rule. What's the product rule, Johnson? What's the little phrase? There you go, 1d2 plus 2d1. Okay, so y prime, we need 1, which is x, d2. What's the derivative of the secant of x? Yep, secant x, tangent of x. So secant x, tan of x, plus 2, which is secant of x, d1. What's the derivative of x? Just 1. Okay, that's going to leave us x, secant x, tan of x, plus secant of x. All right, is there anything we can really do there? Maybe factor out a secant or something. That's about it, isn't it? Let's do that just so we can see what that look like. Secant x, and then x tangent of x plus 1. That's not a terrible thing to do if you have one like that to factor something out, because you never know, you might get something like a sine squared plus cosine squared in the parentheses, which you could replace with a 1 then. You know what I mean? So it's not a terrible thing if you have that in two different things to just go ahead and factor it out to see what you're left with, because you might be able to simplify farther. In this case, you can't, so you're just kind of stuck. All right? Questions? All right, I'm going to give you 3 problems here now. And I'm going to give you maybe yeah. So I'll help you get started. Okay. So give you the functions. F of x equals 4 minus 3x minus x squared over x squared minus 1. So that guy's going to be a quotient rule. Okay. Number 2, this guy is going to be a product rule. So it's the third root of x times root x plus 3. First one's quotient rule. Second one's product rule. And then the third one is going to be a product rule as well. Six x plus 5 x cubed minus 2. Alright, so like I said, I'm gonna give you 10 minutes here. Try to be up there. Give me 1 second. Got it? 6x plus 5. X cubed. It's product rule as well. Alright, so I'm gonna give you 10 minutes just to try these because after we're done with these, we got one more word problem we're gonna do together, and then I'm gonna give you your graded assignment paper. Remember that? Be worth 2 quizzes. So I'll give you that, and you can start working on that or whatever. So there you go. All right, we'll do 1, 3, and then 2. All right, so number one's quotient rule, correct? Quotient rule. I'm going to go ahead and I'm going to erase number 3 for now, just so I have space. But all right. So quotient rule. What's the phrase for the quotient rule? Bingo. Low-D high minus high-D low over the square of what's below. So this is a pretty nice form to try to differentiate when I have to do the tops and the bottom, right? All right. So f prime of x, low, x squared minus 1, d high. So the derivative of the top, 4 goes away. Negative 3x is just going to be negative 3 minus x squared, so that's going to turn into 2x. Okay. Low, d high, minus high, you got the whole thing, minus 3x minus x squared. D low, derivative of the bottom is just going to be 2x over square what's below. X squared minus 1, 20 squared. We good so far? Okay. So if anything, we probably made mistakes after this. It's just simplifying stuff, right? All right, so we have to FOIL the first one, distribute the second one. So I FOIL the first one. Looks like I get negative 3x squared minus 2x cubed plus 3 and plus 2x. The second one, what I'm going to do essentially is distribute this negative sign to the first number. Okay, so I'm going to go negative 4 times 2x. You all right with that? Other than do it and then distribute again. So I'll distribute the negative right now. So I'm going to go plus, minus, plus, plus. All right? So negative 4 times 2x is negative 8x. Negative 4 or 3x times 2x is 6. Oh, I made a mistake right there. 6x squared plus 2x to the third. Yep, mine's wrong. I made a mistake. Uh-oh.
More like mine.
All over x squared minus 1, 20 squared. Okay. So looking across here, the cubes cancel out, right? Here and here. X squareds, I'm going to have 6x squared, 3x squared, negative 3x squared would be 3x squared. Okay. X's, I'm going to have negative 6x and then plus 3. What you got? Okay. All over x squared minus 1, 20 squared. Now, just looking at this, I think I might be able to factor. I'm going to factor this top. I'm going to pull that 3 out first. So 3x squared minus 2 plus 1. Can I factor this guy now? Negative 1 and negative 1, right? So 3 over x squared minus 1. So I factor it, it's going to be 3x minus 1, x minus 1. And the bottom is going to be, yeah, this would go a long way. Because I have x squared minus 1, x squared minus 1. Isn't that the same as that quantity squared? Right? Now then this is the difference of two squares, right? So I can take this guy, x plus 1, x minus 1, right? Gone, gone. This guy here can turn to x plus 1, x minus 1. Gone, gone. That's going to leave me with 3 over x plus 1 quantity squared. Close. There we go. That was a fun one. We all got to hear pretty well, though, right? So we got the differentiation stuff. That's the big part.
I didn't carry the negative through.
You missed the
left
negative.
canceling.
Okay. All right. If we can get to here where that arrow's at, I'm happy. All the rest of the stuff is just honestly mistakes in review.
Yeah, that's where I got to.
And I'm hoping whenever you start doing these again, we haven't really done that much for a while.
I haven't done
Should
algebra
come back.
for over a year.
So, all right. So that would be the final answer. All right. Skip 2 for right now, didn't we? Let's knock out 3 real quick because it's short, sweet. So h of x.
That's, you're right.
This is by far the easiest of the group. X cubed minus 2. All right. So 1d2 plus 2d1, right? So 1 is 6x plus 5. d2, which is 3x. Plus 2. d1. Derivative of the first one's going to be 6. Okay, so then I distribute. Looks like I have 18x to the third plus 15x plus 6x squared minus 12. Right, I'm just gonna, there's no like terms here at all. Wait, this is a third here. Sorry. Third, not a squared. I can't read my own writing.
Is that 3x? 3x squared then? Or no?
This one here?
Shouldn't it be
Yeah,
3x?
it would be 3x squared. That makes this guy 15x squared, makes this guy 18x to the third. Okay, I just didn't write that in. All right, so I can combine two things then. 18 and 6. 24x to the third plus 15x squared minus 12. Did you get that, Johnson?
Yep.
Did you get that one? All right. All right. All right. Now, number 2. How far did you get?
I saw multiplying cube roots and negative exponents, and I quit.
Great attitude to have.
Thank
I didn't.
You just threw up the white flag, huh?
Yeah.
Oh man, I hope you don't do that on your graded assignment. With that graded assignment too, guys, if you have any questions, you can ask me about it. I'll make it due. Go end of the day on Tuesday. Because you guys will be back. Everybody will be back on Tuesday. I'll set aside maybe 5 or 10 minutes. Does that work? End of the day Tuesday. So if you have any, maybe 2 or 3 questions you guys want to ask, you have the same ones you can ask about in class and
You said there was 10
don't know.
questions.
Yeah.
you. Is it this stuff here, product rule? And Quotient Rule?
There's some that's just like a polynomial. You just do each term. And so I think there's like 4 of them. I think there's 4 product rule, 2 quotient rule, something like that. Or maybe 4, 3, and 3. All right, number 2. So we got g of x equals third root of x and then root x plus 3. Right? All right, so first thing I'm going to do, I'm going to rewrite these as powers before I even start. Okay? So I'm going to rewrite this guy as x to the 1/3 and x to the 1/2 plus 3. All right, with that? That way I can just apply the power rule for my derivatives. All right, so g prime of x. 1d2. So 1 d2. d2 would be 1/2 x to the negative 1/2. Plus 2 x to 1/2 plus 3 d1. 1/3 x to the negative 2/3. Okay, we're to there. Now we have to simplify. So the first one, when I multiply, it's the same base. So x's, I have to add the powers together, right? It's back to our power rule days. And the 1/2 comes along. So I'm looking at 1/2. I add a 1/3 and negative 1/2, I'm going to get negative 1/6. Okay, find a common denominator, you get 3/6, 2/6 minus 3/6, which would be negative 1/6. And then on the other side, when I distribute, so I get plus 1/3 x, I have 1/2 plus negative 2/3, which is going to be 3/6 minus 4/6, which would be negative 1/6, right? And then from there, I have 3 times 1/3 x to the negative 2/3, so that's going to be 3 times 1/3 would be 1. So plus x to the negative 2/3. That look right? All right, now I have two of them with the same x power, x to the negative 1/6 and x to the negative 1/6. So I can combine those. And I'm going to have to add 1/2 and 1/3. Add those together, that gives me 5/6 x to the negative 1/6, and there's nothing I can do the other one, so it's just plus x to the negative 2/3. All right, then from there, I can't have negative exponents, right? So I have to take both the x's to the bottom. So this one, I'm going to leave the 5 on top, and I have 6 to x to the 1/6, plus this one here, I'll just reciprocate the whole thing, x to 2/3.
It isn't too bad. It's just a lot of work multiplying
Yeah,
fractions.
and there's a lot of review in there too. You know, you have to remember the power rule for exponents and those types of things. You know, how to factor. Calculus is absolutely a culmination type math. You know what I mean?
Yeah, that's enough for me today.
We got
5 minutes.
we got 5 minutes. Let's run through the last bit. It's super easy, I promise. Okay, it's more so informational than actual calculations. All right, so higher order derivatives. So what we've been doing so far, we're finding the derivative stuff. We're finding what's called the first derivative. Okay, you can go to higher order. You can find the second derivative, the third derivative, the fourth derivative, and so on. Honestly, after the second derivative, things just kind of lose their meaning. Okay, so just as you can obtain a velocity function by differentiating a position function, we found that if we have a function, we find the derivative of it, we find the speed at that point, right? Now, if you do the derivative of the derivative, you find the second derivative. That's the acceleration function. Okay, first derivative is speed, second derivative will be acceleration. Okay, so if we were talking about acceleration, one of the biggest things we're going to see is acceleration due to gravity. Probably did this in physics, yes? If you didn't do it, you're probably getting ready to.
I just failed that test.
Day late, huh? All right, so, but just remember, position function is the original, velocity function is the first derivative, velocity or speed, and then acceleration function is the second derivative. Okay, so we're going to use that for this one. So because the moon has no atmosphere, a falling object on the moon encounters no air resistance. 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon. Position function for each of these falling objects is given by s of t equals negative 0.81 t squared plus 2. S of t is the height in meters, and t is the time in seconds. What's the ratio of Earth's gravitational forces to the moon's? So, just for the record, the Earth's gravitational force, there you go, and we're going to use negative 9.8. Okay?
That's just how it is, buddy.
That's like pi is 3.14. Okay? So so that's the gravitational force pull of the Earth.
Mars is 3.8.
Okay? So you don't know the moon, do you? We're going to find the moon right now.
You know how big the moon is? I don't either. How are you going to
Isn't it like 1/14 the size of the Earth or something like that? All right. So we have the position function, correct? we're looking for acceleration. Okay, so if we want acceleration, we want to find the second derivative. Okay, we have the position function from his experiment on the moon. We have the s of t equals negative 0.81 t squared plus 2. All right, now we find the first derivative. First derivative, all we have to do is apply the power rule, right? 2 goes away because it's a constant, it's equal to 0. So power rule, we're going to have 2 times 0.81. So it's going to be what, 1.62? 1.62 t. All right. Then the second derivative, all you do is just take the one you just found, hit the derivative again of it. Well, if you have the derivative of a constant with a variable to the first power, that's just that. So the moon's will be 1.62.
Goes against a lot of stuff.
So the moon has a gravitational force of negative 1.62. Now we wanted to find the ratio of Earth to the moon, right? So let's go. Here's the Earth force over moon. So the Earth is negative 9.8. Moon is negative 1.62. And that's going to come in pretty darn close to 6. So what does that mean? Earth is like 6 times bigger. All right, 6 times bigger force. We did that using second derivative for acceleration due to gravity. Isn't that fun stuff?